Airbus RACER is the name of this helicopter, and it is far superior to all of its competitors. Something extraordinary is emerging in European skies. It doesn't look like a plane, it doesn't look like a helicopter. We think it's a hybrid of the two. Rapid and cost-effective Rotorcraft, RACER, in short, addresses a common issue in most rotorcraft. How can we make a helicopter fly faster without compromising fuel efficiency, safety, or agility? This aircraft might remind you of a police film, or perhaps they drew inspiration from one. The wing design is different, with short wings and rotors, and by installing two of them, it does the opposite of its competitors. Many people think the owners of this aircraft are cheating, but I don't think so. These wings provide lift strength and reduce the load on the rotor to zero, offering longer flight opportunities. The package also includes minimal fuel consumption and comfort. Comfort is very important. With two Safran Aneto 1X turboshaft engines, each capable of producing more than 2,500 horsepower, the RACER is expected to travel at a speed of 400 kilometers per hour, approximately 250 miles per hour. This vehicle demonstrates that it flies slightly faster than other helicopters. According to Airbus, it will be the fastest rotorcraft in its class. You can review the aircraft's specifications to learn more, but in short, the design is already tailored to achieve this speed. Information from the Eurocopter X3 demonstrator, which stunned the aviation community by achieving a straight-line flight speed of 255 knots, 472 kilometers per hour in 2013, has been utilized. However, the RACER is not just a speed demon. According to Airbus, the most important thing is that they do not want this aircraft to be completed quickly. They want it to have a long service life and a very flexible structure to please users. The aircraft can reduce fuel consumption and CO2 emissions while flying fast by using hybrid features such as shutting off the engine in eco mode during cruise. Advanced control systems, aerodynamic improvements, and composite materials all work toward the same goal. They did not want to incorporate the flaws found in other competitors' aircraft into this one, and they aim for our aircraft to be the best, with the most important goal being to be number one in performance. Speed is a good factor, but it is not the best factor. There are many other important factors. RACER is configured to perform the most important humanitarian activities, such as law enforcement, search and rescue, and emergency medical services, and to operate in harsh conditions. RACER's ability to significantly reduce travel times is crucial, as every second counts, so the helicopter is designed accordingly. If it were not suitable, the outcome would be detrimental. Airbus' commitment to maintaining RACER's cost-effectiveness and operational efficiency is particularly noteworthy. Tilt rotors are much more expensive than older models or new competitors, but this aircraft is worth the price. Compared to its competitors in the same speed class, RACER has lower operating costs, and most importantly, its maintenance is quick and requires much less money than its competitors, which is why it is widely used as a military vehicle or for humanitarian aid. What is the current status of the RACER? The prototype is currently undergoing ground tests and final integration at Airbus Helicopters facility in Marignane, France, with the aim of completing these by 2025. The first flight is expected to take place soon, potentially marking the beginning of a new era where rotorcraft no longer have to choose between sustainability, safety, and speed. Will Airbus RACER, in a world of urgency, mobility, and climate change, be more environmentally friendly than its competitors and deserve to be the #1 aircraft of the future? While it is highly technological, the most important factor is that it is far ahead in terms of design. This design serves as a benchmark for every aircraft resembling this one worldwide and acts as a pioneer for each aircraft. Unlike American projects such as the Bell V-280 Valor and Sikorsky Boeing Defiant X, which focus on military dominance, speed is not a crucial factor for RACER, as it is intended for civilian use. The most important thing is not war, but rather the ability to save human lives quickly and efficiently, which requires extraordinary speed. Airbus is refusing to collaborate with its competitors, insisting on going it alone. Clean Sky 2, a public-private partnership within the European Union, aims to develop new generation aircraft with lower emissions, noise levels, and environmental impact. RACER is part of this initiative. This means that RACER is not just a business venture, but a full-fledged effort to provide assistance. Over 40 partners, including research institutions, small and medium-sized enterprises, and universities, are supporting its development. This partnership is about more than just engineering. Everything is progressing very positively and smoothly because everyone involved is working towards the same goal. From a structural point of view, Racer's unique combination of main rotor and propeller rotor adds elegance and complexity. The way this aircraft flies is that the side rotors enable horizontal flight, while the other vertical rotors enable vertical takeoff and landing. Thanks to the separation of lift and thrust, the aircraft can fly like a helicopter, capable of vertical flight. And considering the speeds of aircraft, it also has the ability to fly at such speeds. Additionally, since the propulsive rotors are powered by the same engines, the propulsion system remains relatively simple and reliable as a whole. The main reason for this is that it offers customers good opportunities by spending less money on maintenance instead of spending a lot. Airbus plans to use modular cabin configurations within the aircraft that can be quickly adapted to various tasks. For example, if you need to travel 200 kilometers, do you know how it would fly for a patient? I don't think so. It would fly like an ambulance with a jet engine attached. Do you need sensor packages to monitor forest fires? RACER is perfect for rapid deployment thanks to its speed and range. A platform like RACER, which combines the efficiency of fixed-wing aircraft with runway independence, can easily move to the designated landing sites and take off comfortably. The important thing is that RACER is not a prototype that will be put in a museum after a few test flights. Airbus does not want it to be a viable product or to be commercialized. Its main goal is to establish a humanitarian aid initiative to help people. The aviation and space community is closely following this as the first flight approaches. Will RACER meet expectations during the flight? Will the cost and speed advantages of this new design outweigh its disadvantages? Additionally, if Racer is successful, they will not only redesign helicopters, but also decide to redesign other conventional aircraft. Has the time come for helicopters to transform into something completely different? Racer's future flight test will not only demonstrate its feasibility, but will also test everything this company has done to see if it complies with these tests or if it can withstand all adverse conditions. On paper, this goes beyond speed. When compared to traditional helicopters like the H-145 or larger models like the H-225, Airbus claims that RACER will travel at approximately 400 kilometers per hour, 250 miles per hour, which has been widely praised. However, speed is not the most important factor, as it is understood that speed is crucial when saving human lives. The most important factor in this speed is that it can quickly transport someone who is on the brink of death to the hospital in the final moments. It can reach a sinking ship 50 kilometers away in open water several minutes faster than a traditional helicopter. Previously, ground-based or slow aircraft were forced into the search and rescue team because they were overtaken by this aircraft, and older or low-performance aircraft were sent elsewhere. Additionally, unlike experimental concepts locked away in government hangars, RACER aims for real-world operational deployment in both the public and private sectors. Racer also has an advantage in terms of sustainability. Compared to its competitors, it is made with lightweight materials at a lower cost and prevents excessive fuel consumption, thereby reducing noise and avoiding disturbance to people in the vicinity. Since green aviation is no longer optional but mandatory, more environmentally friendly aircraft are gaining prominence, so this aircraft will be used more in the future. However, public perception and acceptance may be the most intriguing challenge. Will everyone feel confident about this aircraft, as it resembles a spaceship rather than a conventional helicopter? Will RACER's speed be valuable enough to justify the investment for governments and emergency services? Most importantly, will Racer, like the Concorde's supersonic dreams, inspire its competitors to create new aircraft or spark new ideas? A revolutionary development in helicopter design has long been anticipated by the aviation industry. Airbus is not only seeking to improve helicopters with Racer, but also to redefine them. However, are we ready to accept not just a better helicopter in the future, but one that is fundamentally different? To understand the concept behind this aircraft, we must first thoroughly research the general characteristics and principles of helicopters. Helicopters have been subject to the same aerodynamic limitations for years. A realistic maximum speed of approximately 250 kilometers per hour, 155 miles per hour. Pushing beyond this limit can cause imbalances in airflow, leading to one side of the rotor losing lift, which could cause the wing to stall or break, leaving passengers feeling unsafe. Over the years, engineers at Bell, Sikorsky, and Eurocopter, now Airbus helicopters, have struggled with this limitation. What was the only solution? It lay in understanding the helicopter's limitations. With the emergence of the military-specific V-22 Osprey, the tiltrotor era officially began. It had significant mechanical, political, and financial costs, but it could fly fast and over long distances. With Racer, Airbus easily invented a tiltrotor with a quick idea that came to mind without much thought. RACER therefore does not tilt its main rotor. They added something that leaves the rotor idle, thinking there was no need for it, and two propellers to push it sideways. You might think this has a lot of effects. The result? It combines the speed of an airplane with the vertical takeoff and landing capabilities of a helicopter. According to Airbus, this is a delicate balancing act that could eventually break the speed barrier without compromising on cost or efficiency. More importantly, RACER is not just a defense-oriented prototype or a one-off demonstrator. This thing is approved for many things, such as saving human lives or for special purposes in medical cases. This is a significant change. It means that RACER could be the first rotorcraft to offer next-generation performance to non-military operators. The risks are very high. If RACER is successful, it will have the chance to go down in history as the fastest rotorcraft in the world. If it fails, it could confirm what many people fear, that fast helicopters are too expensive, so no one will buy this aircraft, and it will crash from the top to the bottom in an instant. However, throughout history, every revolutionary aircraft has faced the same skepticism. The original Bell 47, the SR-71, and even the Concorde. Racer's goal is to push the limits of helicopter flight, potentially even breaking the sound barrier. The only question that comes to mind is, will everyone produce very fast aircraft in the future? And will these eventually be replaced by slower ones? Or will the fast ones prevail? We will see this in the future. To find out, follow us and join the discussion in the comments.